Hi, I'm Scott Vall, LSAM Product Manager here at Thermwood. LSAM is Thermwood's line of large-scale additive manufacturing systems. These advanced systems have become both the technology and market leader in large-scale additive production of reinforced thermoplastic composite materials. After several years of initial technical development, we began shipping these systems to customers. So how did we achieve the #1 position so quickly? Most likely, it's the continuous cooling print technology we developed. This approach is not only different, but better. We have already been granted almost 50 patents on these developments, and more are coming. This technology and the unique print head design we developed to implement it results in part quality that cannot be duplicated on any other system today. Parts produced on Thermwood's LSAM using our compression wheel are almost twice as strong as parts produced using a tamping plate, and almost 3 times as strong as parts produced by just extruding beads on top of one another. LSAM produced molds are so homogeneous and void-free that they routinely hold vacuum to aerospace standards in a heated, pressurized autoclave without a separate seal coating. Our aerospace customers do it every day. So it's not surprising that Purdue University's Composites Manufacturing and Simulation Center found that LSAM printed structures were fully fused, homogeneous, and virtually void-free. In addition to high-temperature aerospace tooling, LSAM parts are being used in a variety of other applications, including the 93-foot-tall commemorative torch recently announced at the Allegiant Stadium in Las Vegas, the new home of the Las Vegas Raiders. This was produced by our customer Dimensional Innovations and is believed to be the tallest 3D printed structure in the world. It required their LSAM to run around the clock continuously for almost a year, a real testament to its reliability. Yes, LSAM is the clear leader in this market. However, the cost of our flagship systems can be prohibitive for some companies. We sometimes hear from companies who don't want to make the world's largest anything, but do want to benefit from our advanced print technology. The vast majority of these companies do need rather large parts, but do not need the huge tables or massive print heads on our flagship machines. There seems to be a growing need for high-quality printed composite parts in industries other than those we currently serve. To address this, we have taken a different approach. Near-net shape additive parts need to be both printed and trimmed to final size and shape. Our flagship machines, like this one, do both printing and trimming on the same machine. These systems can both print and trim at the same time, provided both the print and trim part will fit on the table at the same time. They can also print and then trim massive parts as long as they fit on the machine. They are also able to vertically print parts as long as the table, which to date can be up to 40 feet. These are truly huge, capable systems, but not everyone needs all that. Our MT and 1010 systems are a bit smaller and somewhat lower in price. They do use the same massive print and trim heads as the big machines and can also both print and trim, but not at the same time. To make this technology work for even more companies, we decided to offer somewhat smaller print-only additive machines. Let me introduce the LSAM Additive Printer. We did this for 2 reasons. First, many of the companies asking for these machines want to print parts that they currently machine from solid blocks of material. They want to switch from subtractive to additive. Additive printed parts require significantly less machining than the full subtractive process. In these cases, changing to additive can significantly free up existing machine time. These companies don't need more machining capacity. They already have more than enough. The second reason is that a print-only machine with a 30mm LSAM print head can be built for considerably less than a full print and trim machine. This smaller machine does not have to handle a print head weighing well over 2 tons. We did our initial development work using a 30mm print head and then switched to the larger head for the larger production machines. For these new print-only machines, which we call LSAM Additive Printers, we updated and refined our original print head so it could operate using a machine structure similar to the 5-axis CNC routers we have been building for decades. We utilize some more advanced tab and slot steel structure like on our large machines, but it's still significantly reduced cost. You don't have the massive table of the flagship machines. However, you can buy one of the new LSAM additive printers and an LSAM additive trimmer for just a bit over a third the cost of our smallest dual gantry flagship machine. This is a real game changer for a lot of companies and has the potential of changing this industry. The 30mm LSAM print head has a maximum print rate of about 100 pounds per hour versus 200 pounds per hour for our 40mm print head, which is standard on our flagship machines, and over 500 pounds per hour for the optional 60mm print head. This print rate shouldn't be a problem since 100 pounds per hour is already greater than about anything else out there. It can easily print the vast majority of parts that these new customers want. The LSAM additive printers use the exact same control as all other LSAM systems with all their advanced features and capabilities. It uses the same LSAM Print 3D software for slicing and programming. It's pretty much the same other than it's a little bit smaller. There are 2 table sizes available on the LSAM additive printer, 5 foot by 5 foot and 5 foot by 10 foot. The 5 by 10 foot size comes in 2 configurations, 5 foot wide with 10 feet of front to back movement, or 10 foot wide with 5 feet of front to back movement. The choice depends primarily on factory layout, since both are the same price and can make the same parts. All the LSAM additive printers have a vertical working envelope of 4 feet. The machine table comes standard with a single servo drive, giving it a 1,000-pound maximum weight capacity. This can be doubled on the 10-foot wide table by adding a second drive. We are also working on adding a vertical layer printing option to the 5-foot wide, 10-foot deep machine. This will support parts up to 10 feet tall, which is ideal for a lot of tooling applications. When you think about it, these tables aren't all that small. The machine is available in an open configuration, which can work for many companies. Or, if you want, you can add an optional full enclosure as you see here. The enclosure and machine can be built to European CE standards if needed. This particular machine is Thermwood's demonstration additive printer. It has a 10-foot wide by 5-foot deep single drive table and a full enclosure. So the LSAM additive printer offers another approach to high-quality composite additive manufacturing, provided the envelope, size, and print head output are adequate for the parts you want to print. Now let's look into more detail at some of the features of the LSAM additive printer. This is the print head. As with all LSAMs, it uses a patented screw which operates at high speed compared to normal industry extruders, and gets the majority of heat needed to melt the polymer from ceramic barrel heaters rather than screw friction. It can process at temperatures up to 450 degrees Celsius, which is about 840 degrees Fahrenheit. These temperatures can process pretty much any thermoplastic polymer used for additive manufacturing today. Most extruders today melt the polymer primarily from heat generated by screw friction. But we found that this does not work for additive manufacturing. For traditional extruders to generate and maintain even heat, the screw needs to run at a constant speed. But screw speed on an additive machine is constantly changing, sometimes very rapidly. Also, with traditional extruder screws, the geometry of the screw is often tailored to the polymer it will run. To efficiently run different materials, you may need to change this geometry, which means changing the screw each time you change polymers. This doesn't work well for additive. Our patented high-speed screw design and high-intensity barrel heating system can run about anything. Our system solves these problems. It also solves another common extruder problem called surging. With a typical plastic extruder today, even if all parameters, speeds, and temperatures are kept absolutely steady, the output will not necessarily be even. It will be even most of the time, but ever so often, output will vary. This creates flaws in the printed part. This is a well-documented problem called surging, and it just doesn't work for additive. Believe me, we've tried. To make it work consistently, we added a servo-controlled polymer metering pump, which takes the output from the extruder and meters it precisely to the nozzle. This, plus some other fundamental structural and geometric changes within the extruder and pump combination, along with some clever and patented electronic and software features, gives us absolute control of the output at all print speeds. Yes, we solved the surging problem. It wasn't all that easy, but it works. The 30mm LSAM print head has the same nozzle and compression wheel assembly as the larger machines. This compression wheel approach results in superior fusion between printed beads, creating a homogeneous, virtually void-free structure. These structures have shown to be 2 or 3 times stronger than any other method of FDM printing available today. Producing near-perfect parts requires absolute temperature control of every aspect of the process. In addition to heating, many system components require controlled cooling. The additive printers come complete with a liquid chiller and plumbing to control the temperature of vital components, including, among others, the liquid-cooled extruder servo drive and the compression wheel. This is vital, especially when processing materials at high temperature. Another requirement for quality printed structures is absolutely dry polymer. The LSAM Additive printer includes a programmable polymer drying system with a single 600-pound capacity hopper, capable of drying all materials that the system can run. If you are going to run the same material all the time or change material infrequently, this will work fine. However, if you are going to change materials regularly, you may want to consider upgrading to the dual hopper system like the one standard on the flagship machines. With a single hopper, if you are running the same material, you can keep adding material and drying it while you print. If you need to change to a different material, you need to empty the hopper, load the new material, and run through the drying cycle for that material. The initial drying cycle typically takes several hours. With the dual hopper, you can be drying the new material while you are printing the first material. When you are ready to change, you just switch to the new one with no delay. The LSAM Additive printers include a built-in fume extraction system. Many polymers emit smoke or fumes while printing, which can be objectionable, so it is important to either vent or otherwise treat these vapors. The fume extraction system pulls fumes upward into the gantry through specially designed activated carbon filters intended specifically to capture and treat these fumes. Then it exhausts it back into the room. I would like to show you one additional new optional feature that is really exciting. It is standard on the flagship machines and optional on the additive printers. It has the rather long name of Thermal Sensor Layer Automation. What it does is rather basic, but both unique and important. This thermal sensor is embedded in the servo-controlled rotary mechanism that carries the compression wheel. It is mounted so that while printing, it continuously reads the temperature of the existing bead, right in front of the moving nozzle, an instant before the new bead is added. Each polymer that we print with has a temperature or small temperature range where the absolute best fusion between layers occurs. To get the best possible parts, you need to print at or very near this ideal temperature. Today, this is handled by an exclusive patented LSAM feature called layer time control. With layer time control, the operator watches the print temperature using either a thermographic camera or a hand thermal measuring device, and if they see it varying from normal, they can adjust the layer print time dynamically to bring the temperature back in range. This already works better than anything else out there, but does rely on a level of operator skill and judgment. It would be nice if the temperature range could automatically be kept closer to the ideal than what even a really skilled operator is capable of doing manually. This brings up thermal sensor layer automation. The thermal sensor reads the bond temperature at every point along the layer and, using an advanced algorithm, adjusts the print speed to bring the layer as close to the ideal temperature as possible. And this is all automatic. At this point, it is a completely closed loop operation. Operator skill, judgment, and manual adjustments are no longer needed. You don't need a polymer specialist. About anyone capable of running a normal CNC machine can run the LSAM additive printer and achieve absolutely optimum results. This is especially important for the LSAM additive printers, since many companies who are interested in this technology don't have large additive manufacturing staffs or polymer experts on board. An LSAM additive printer with layer automation can very likely be run by existing employees with just a little training. There is one more area I would like to cover, and that is trimming. Earlier, I mentioned using a Thermwood LSAM additive trimmer for trimming. This is a typical 5-axis head available on an LSAM trimmer. This machine is available with the same table sizes and configurations as the LSAM additive printer. It has enough over travel in all directions so it can travel all the way around the working envelope horizontally and can reach every area of your largest printed part from every orientation. It is also available with a 5-foot vertical stroke, so not only can it trim completely around, but also over the top of the largest part you can print. If you need a trim system for your printed parts, this is a great choice. There are a lot more details, but in general, this is the LSAM additive printer. If your parts fit, this is the lowest cost way of accessing industry-leading LSAM print technology. If you would like to explore this further, give us a call. We look forward to hearing from you.